students, myself Hanasha, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss few more topics of sequence and series. Let us begin with the first topic, that is Cauchy's root test. So if you are given un as a positive term series and if limit n tends to infinity un whole raised to 1 upon n is equals to L, then the series converges for L less than 1, the series diverges for L greater than 1, and the test fails for L is equals to 1. That is, we have to apply some other test. Now we will apply Cauchy's root test if our un is of the form Vn whole raised to n. So we will apply whenever we are given n raised to n or 3 raised to n. Whenever you see the power n in our series, we will apply Cauchy's root test, right? So let us solve few examples. Firstly, we have to test the convergence of the series summation n is equals to 2 to infinity 1 upon log n whole raised to n. Here the series is starting from n is equals to 2 because if we put n is equals to 1 here, we will get 1 upon log 1. But the value of log 1 is 0. So 1 upon 0, that will give us infinity. So our series is undefined at n is equals to 1. So now let us start the solution. Here you are given un as 1 upon log n raised to n, right? Now we will find un raised to 1 upon n. So this n and n will get cancelled out. So what will remain? 1 upon log n. Now let us find the limit n tends to infinity un raised to 1 upon n. Put the value of this term. So finally put the value of limit then. As n tends to infinity, this will go to log infinity. Now the value of log infinity is what? Infinity. And 1 upon infinity will be equals to 0, which is less than 1. Therefore, we can say that our series is convergent by root test. Okay. Next, let us solve one more example. Is the series summation n is equals to 1 to infinity n into e raised to n convergent? So here you are given your un as n into e raised to n. Again find un raised to 1 upon n. So put the value of un, that is n e raised to n whole raised to 1 upon n. Now let us find the limit n tends to infinity un whole raised to 1 upon n. Put the value of this term, that is un raised to 1 upon n. Now here you can see n and n gets cancelled out. So what is remaining? E times limit n tends to infinity n raised to 1 upon n. Now we know the value of limit n tends to infinity n raised to 1 upon n. It will be equals to 1. So what we will get answer as E, that is greater than 1. So given series un is what? Divergent. Okay. Next, we have to test the convergence of the series 1 cube upon 3 plus 2 cube upon 3 square plus 3 cube upon 3 cube plus and so on. So here firstly we will find our un, that is our nth term. So here in the numerator you can see 1, 2, 3. So our series is what? N raised to 3 upon. In the denominator you can see the powers of 3. So that is written as 3 raised to n. Now find your un raised to 1 upon n. So that will be equals to n cube upon 3 raised to n whole raised to 1 upon n. Now find limit n tends to infinity un raised to 1 upon n. That will be equals to limit n tends to infinity n cube upon 3 raised to n whole raised to 1 upon n. Now you can see this n and n gets cancelled out. So what is remaining? Limit n tends to infinity n raised to 3 by n upon 3. Okay. Next, we know the answer of the limit n tends to infinity n raised to 1 upon n, which gives us answer 1. Okay. So finally you will get answer of the limit n tends to infinity un raised to 1 upon n as 1 upon 3, which is less than 1. Therefore, our series is convergent by root test. Okay. Next, let us define alternating series. So whenever you are given an infinite series with alternate positive and negative terms, it is known as alternating series. So for example, 1 minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square and so on. Here you can see alternate negative and positive terms, right? So this series is an alternating series. You can write it in the form as summation n is equals to 1 to infinity minus 1 raised to n minus 1 upon n square, right? So for this type of series, we will use our next test, that is Leibniz test. Okay. So if alternating series summation n is equals to 1 to infinity minus 1 raised to n minus 1 un, that can be written as u1 minus u2 plus u3 and so on, where our nth term is greater than 0, satisfies the following conditions. So the first condition is mod un greater than mod un plus 1 for all n. That is, our series of positive terms should be what? Decreasing, right? And next, if limit n tends to infinity mod un is equals to 0, then the series is convergent. That is, for alternating series, we have to check these two conditions. If both the conditions are satisfied, then only we can say that our series is convergent. Okay. Now let us start solving example. So test the convergence of the series summation n is equals to 1 to infinity minus 1 raised to n plus 1 upon log n plus 1. Right. So let us start the solution. Here looking at minus 1 raised to n plus 1, you can say that our given series is an alternating series. Okay. So next, let mod un be equals to 1 upon log n plus 1. We have taken mod and selected only positive terms, right? So mod un is equals to 1 upon log n plus 1. Now let us start applying our condition. So first condition is mod un minus mod un plus 1, right? So put the value of mod un, that is 1 upon log n plus 1. Now write mod un plus 1. Just replace n by n plus 1 in this. So you will get log n plus 1 plus 1. So it will be written as log n plus 2. Okay. Now simplify by taking LCM. So you will get log n plus 2 minus log n plus 1 upon log n plus 1 into log n plus 2. Now suppose if you put n is equals to 1 in our numerator, what you will get? Log 3 minus log 2. And if you take the values of these two and subtract, then you will get answer greater than 0, right? So our first condition, that is mod un greater than mod un plus 1 is satisfied. Okay. Next, let us find limit n tends to infinity mod un. Put the value of mod un, that is 1 upon log n plus 1. Now as n tends to infinity, this log n plus 1 goes to infinity and the answer of 1 upon infinity will be equals to 0. So both the conditions of our Leibniz test are satisfied. Therefore we can say that our series is convergent. Okay. Next, let us solve one more example. Here we have to test the convergence of the series 1 minus 1 upon 2 root 2 plus 1 upon 3 root 3 and so on. So here too we will firstly find our nth term un. But before that, here you can see alternate positive and negative terms. Therefore our given series is an alternating series. Now let us find our nth term, right? So nth term will be minus 1 raised to n minus 1. Here you can see that, here you can write 1 into root 1. So 1, 2, 3. So it will be written as n. And again you can see root 1, root 2, root 3, root 4. That can be written as root n. Now let us write our mod un. So mod un is equals to 1 upon n root n. So what will be our mod un plus 1? Just replace n by n plus 1. So it will be equals to 1 upon n plus 1 times root n plus 1. Now let us find mod un minus mod un plus 1. So that is equals to 1 upon n root n minus 1 upon n plus 1 times root n plus 1. For example, take the value of n as 1. So what you will get? 1 upon 1 root 1 minus 1 upon 2 root 2, right? And here you can see it will be 1 minus 1 upon 2 root 2. If you subtract these two, you will get answer what? Greater than 0. Therefore, we have satisfied the condition, that is mod un greater than mod un plus 1. Now let us find the limit n tends to infinity un. That is equals to limit n tends to infinity 1 upon n root n. But as n tends to infinity, 1 upon n will go to what? 0. So our answer of the limit is 0. Both the conditions of the Leibniz test are satisfied. Therefore, our given series is convergent. Okay. So in today's session, we have studied firstly which test? Root test. Right? So if your question is in the form un is equals to bn whole raised to n, then you will apply which test? Root test. In this you have to find L is equals to limit n tends to infinity un raised to 1 upon n. Here if L less than 1, then our series un is convergent. If L greater than 1, then our series un is what? Divergent. And if L is equal to 1, then our test fails and we have to apply some other test, right? Next we have studied alternating series, right? Which is of the form summation n is equals to 1 to infinity minus 1 raised to n minus 1 times un. That is, you will be having alternate positive and negative terms. So in this type of series, you have to apply which test? Leibniz test, right? So in this test, you have to test two conditions. That is, first is mod un minus mod un plus 1 should be what? Greater than 0. And second condition is limit n tends to infinity mod un should be equal to 0. Then only we can say that our given alternating series minus 1 raised to n minus 1 un is what? Convergent. Okay, so I hope you have understood throughout the session. Thank you for watching.